Hi guys, Mathemagic here. Today we're going to be using some simple arithmetic to absolutely destroy some of the key arguments used by flat earthers, and how just because the earth looks flat, as seen here, doesn't mean it is. Let's get right into it. One of the lesser known kind of arguments in the flat earth conspiracy is the idea that instead of gravity being provided by a mass, dark energy is actually accelerating our flat earth upwards at 9.8 meters per second, kind of like this. So if we have our flat earth here, we've got a force provided by dark energy accelerating this up at 9.8 meters per second squared. So essentially, if I push down on this table, I'm not going to be able to go any further because the table is moving up and accelerating. There is one completely blindingly obvious fault with this. If we know velocity is equal to acceleration multiplied by time, we can find out how fast the Earth is moving at any one point after it has begun accelerating. We can assume that according to flat earthers, well, the Earth is 6,000 years old, so we'll go with that. So we'll go multiplied by time. So we've got 6,000 multiplied by 365.25 days. We'll just average it out from leap years. Multiplied by 24 days, multiplied by 60 hours, multiplied by 60 seconds. And our velocity we get is 1.86 multiplied by 10 to the 12 meters per second. So 6,000 years after the beginning of the acceleration, we're apparently moving at 1.86 times 10 to the 12 meters per second. This seems, fine if you don't consider Einstein's special relativity, which states that nothing can travel faster than the speed of light, and you're going to get heavier and longer the shorter actually the closer you get to the speed of light. So our number here is roughly a couple of 10,000 times larger than the speed of light. So according to the theory that dark energy is accelerating us upwards and there's no source of gravity, we are indeed moving tens of thousands of times faster than the speed of light and only getting quicker. So our second argument concerns itself with the magnitude of the curvature of the Earth. Now, flat earthers claim that when they go and look out on the horizon, maybe it's the ocean or a big open expanse or whatever, they can't see the Earth's curvature. Now, if we imagine that this is our surface of the Earth here, and we want it to curve, say, downwards of about 5 centimeters, like this. So this is 5 centimeters. You think maybe I need 100 meters to curve down 5 centimeters. Maybe I need 200 meters. The truth is, every 80 meters that you go horizontally, you're only going to drop 1 centimeter. That means you're going to need to go 400 meters horizontally before we can even see this 5 centimeter drop. So if I had another 1,346 pieces of paper and I continued this line way out, you can see if I got another piece here and continued the line, it's not going to make a difference. We're still looking at over 1,300 pieces of paper just to get a 5 centimeter drop. This is why it is completely absurd to rely on your own eyesight to really determine the magnitude of the curvature of such an enormous sphere. So I've got some examples here to show you how ridiculous it is how flat earthers rely on their own senses. So here we have a football oval. From the position where I'm filming this from and to the grandstand is 140 meters according to Google Maps, and that is only going to give us 1.75 centimeters of curvature. Next example, we've got a nice flat train bridge here, same length, 140 meters, yet again only going to give us 1.75 centimeters of curvature. Next example coming up, we've got some cricket pitches here that are 35 meters long. Across the end to end of these cricket pitches, you're really going to get less than 5 millimeters of curvature across them, which just shows how ridiculous it is. You're never going to see that with your own eyes. Alright guys, let's get right into the final argument here. We don't want to waste any more of our time on the flat earth conspiracy. So for this argument, I'm going to be using a mixture of data. We'll say it's favouring the flat earthers with this data, but I'm still going to be able to show you how it just doesn't add up. So according to flat earthers, the orbital radius of the sun is 4,828 kilometers. It's important to note that they claim that the sun orbits the earth, this disk kind of like this, in this circular directly above the earth. And then day and light cycles work like this, moving around. Anyways, they also claim that our flat earth kind of bubble is 6,000 years old. From our own observations, not necessarily related to flat earth at all. The power of the sun is 3.86 times 10 to the 26 watts, and it is projected that the sun is going to last for another 5 billion years before it turns into a white giant or a red dwarf or whatever it's called. Anyway, that being said, that total lifespan of the sun is going to be 6,000 years plus the 5 billion years projected further on. So let's get right into it. So total energy produced by the sun in its lifetime is going to be equal to power multiplied by time. So we're going to get 3.86 times 10 to the 26 multiplied by number of years. So 6,000, as I said, 6,000 plus 5 billion multiplied by 365.25 average days in a year by 24 hours, 60 minutes, 60 seconds. And that's going to give us a total energy 6.09 times 10 to the 43 joules emitted in the entire lifespan of the sun. And we can use this entire energy to figure out how much the sun weighs using Einstein's famous E equals mc squared. We can say that 6.09 times 10 to the 43 is equal to mass multiplied by the speed of light squared, and that'll give us a mass of 6.76 multiplied by 10 to the 26 kilograms. That is a lot of mass, especially considering we're only 4,800 kilometers above the earth at any one point. And I'm sure you'd start to see the problem here. We're going to have a huge, absolutely massive gravity exerted by the sun at such a small distance away from it. So if you use Newton's gravitational constant and some other values, you can figure out that if you were standing directly underneath the sun, you would experience 952 million Gs. And I'm sure you can realize that you can go outside and you're not going to get launched up to the sun at catastrophic speeds. I'm sure there are some quite obvious problems with having such a large gravitational value of the sun. That's it for this video, guys. Thanks very much for watching. Hopefully you learned a bit about destroying some flat earthers arguments. I'll see you all in the next video.